Hey guys, Mrs. Sands here. So we are on lesson 9. It's a very short video because really you already know how to do it. We're combining two concepts together that we already know. We will be solving quadratic equations by completing the square, which means you get it into vertex form, which we learned like 2 weeks ago, and we even had a quiz on it. And then you use inverse operations, which we practiced yesterday. The one new thing about inverse operations that we learned yesterday was that if something is being squared, to undo it, you square root it. I want you to remember that all positive numbers have two square roots. Remember, so you have to put that plus or minus sign in front of that radical sign. Your homework answers are posted in Google Classroom from last night, lesson 8's homework answers. You can maybe give the do now a try, but I am going to go over it with you. Our plan for the day is that you're watching the video and then you get to work on the rest of the questions in the lesson because your homework really is to finish the lesson. So it's really not too much. You might finish it all in class. So like I said, we'll be solving quadratic equations by completing the square, which really means first getting into vertex form, then use inverse operations. So you do now is review of yesterday. So a is being squared, so to undo it, I square root both sides. Remember, all positive numbers have two square roots, so you put a plus or minus sign in front of it. The square root cancels out the square, you're left with an a. And what is the square root of 625? Maybe it's a perfect square, so the first thing I'm going to do is check on my calculator. So square root of 625 is a perfect square. It's 25. So this is plus or minus 25. Done. Number 2, the parentheses are being squared. So I will square root each side to undo the squaring. All numbers have two square roots, so don't forget your plus or minus. So a minus 3 equals plus or minus 6. We add 3 to both sides, and this is going to give us two answers. It might be 6 plus 3, which is 9, or a might be negative 6 plus 3, which is negative 3. We could write it in the set notation, so the answers are 9 or negative 3. So let's solve this equation by completing the square. So just like what we did in lesson 4, it's already set equal to 0. Remember, if it's not set equal to 0, it's supposed to get it equal to 0. And remember, I like to underline the first two terms. It reminds me that's where I'm undistributing. You undistribute the coefficient. So we'll take out the 2 from what I underlined, which means I'll be left with an x squared plus 6x. Remember, you leave a gap and you put the plus 1 on the outside, and you leave another gap, and it does equal 0. Remember what we do next. So we take half of the 6, which is a positive 3. That positive 3 has to get squared, which is a 9. Don't forget, though, this 2 times 9 is an 18. Therefore, I subtract 18. So that's the thing that people forget sometimes, to multiply that number that you write inside by what you undistributed. So now what I have is, I just want to change my color, 2 times x plus 3 times x plus 3 plus a negative 17 when I combine like terms, right? The reason why it's called completing the square is because I just made this trinomial factored into two perfect squares. So I'm left with 2 times x plus 3, quantity squared, plus a negative 17. So this whole step right here, we just got it into vertex form. We completed the square. So now we use the properties of equality to solve for x, meaning our inverse operations. So if I have 2 times x plus 3 squared minus 17 equals 0, the first thing I should do is add 17 to both sides. What I want you to remember that this is like PEMDAS backwards, right? I undo the adding or subtracting first. Then I undo the multiplying or dividing. You might want to write it as like 8.5. Then I have to undo the squaring. All positive numbers have 2 square roots. The square root cancels out the square. And then I subtract 3. And we usually write the rational number first, then the plus or minus sign, and then the irrational number. This is kind of as far as I could go because the square root of 8.5 is irrational. So notice it says answer in radical form, which means it's an exact answer. So I have that x equals negative 3 plus or minus the square root of 8.5. Then it says a rounded answer. So now we're going to use our calculator. I want you to type in exactly what our exact answer is into the calculator. So we have negative 3 plus, you can only hit a plus or a minus, you can't hit them both, so I'll do the plus first, plus the square root of 8.5, and I get that. So I'll write that answer down. Does it say what to round to? No. Usually they tell us where to round to. Let's round to the hundredths. So negative 0.08. Or, because remember I just hit the plus sign in my calculator. Now I want to do negative 3 minus the square root of 8.5. And I get negative 5.92 if I round it properly. If I'm rounding to the hundredths place, that 5 makes the 1 round up. Negative 5.92. And that's it. That's the lesson. So you know how to complete the square. You know how to use inverse operations, and you know how to use your calculator. I will do like one more with you. So I guess we will do number 1. So if we follow the steps that I said, first we want to get it into vertex form. Then we want to use inverse operations. And then we want to write the roots. And it tells us both in exact answer and rounded to the tenths place. So these are like side notes to help remind me what to do. Vertex form first, inverse operations next, and then I'll have my roots, and I have to list in both exact and rounded. So let me just zoom in so that you can see a little bit better. If I get it in vertex form, I want to get set equal to 0. Then I want to underline my first 2 terms. I want to undistribute the 1. I want to leave a gap, leave another gap. Then I want to take half of this plus 2, which is a 1. I want to take that 1 and square it, which is a 1. I do the 1 times 1, which is 1. The opposite of 1 is minus 1. Almost there. I usually skip this next step that I'm going to write down. 1 times x plus 1 times x plus 1 minus 25 equals 0. I usually skip that because I know that the parentheses are going to be the same, so I usually come straight to this step. So you can go from here to here. All right, now it's time to follow my inverse operations. So let's add 25 to both sides. I don't really need that 1 in front of the parentheses, so I'm not going to write it. Let's now square root each side. Don't forget your plus or minus. Square root cancels out the square. So I have plus or minus 5. This one was pretty straightforward. The answer turned out to be 2 rational numbers. It's going to be 5 minus 1 or negative 5 minus 1. So x is either 4 or x is negative 6. And that's it. So sometimes our answers are both rational, sometimes they're irrational. I am going to provide you with a list of answers in Google Classroom. I'm going to just look and see if there's another one that's irrational that I can do with you. So we can do number 2. Number 2 turns out to be irrational. Vertex form first. We'll subtract 4. I will underline the first 2 terms, undistribute the 1, leave a gap. I will take half of that 12. I'll square it and put it here. And 1 times 36 is 36. The opposite of that is minus 36. So I'm going to go straight to my parentheses squared. It's a p plus 6. And when I combine this, I get 90. Now I have to follow inverse operations. We'll subtract 90 from both sides. I don't need the 1 in front, so I'm not going to put it there. If that was another number, you would need it, and you'd have to divide both sides by it before you square rooted. I feel like I did something wrong. I see my mistake. Notice how I caught my mistake pretty quickly. I'm not even going to edit this video. It's a good learning experience. The reason why I know I made a mistake is because I know all of these have an answer, and I was going to square root both sides next, and you can't square root a negative number. So I knew I made a mistake. I see it right here, negative 54 minus 36. This is a negative 90, not a plus 90. So this should be minus 90. Therefore, I'm going to add 90 to both sides, and now I'm okay. So now I'll square root both sides. Don't forget your plus or minus in front. Square root cancels out the square. So 90 is not a perfect square either, but it can be simplified. So I don't know. You can subtract 6 from both sides first and then simplify your 90, or you can simplify your 90 first. It doesn't matter. So watch. I could subtract 6 from both sides. And let's say that p equals negative 6 plus or minus square root 90. But I have to know that I'm not done. I should know that this could simplify into square root 9 times square root 10, which is 3 rad 10. So P equals negative 6 plus and minus 3 rad 10. So that's probably the most efficient way of doing it. And this is an exact answer. If I want the rounded answer, I just open up my calculator. And in your calculator, type exactly what you see. Negative 3. Wrong. Sorry. Negative 6 plus 3 square root 10. Right? My screen looks like what's just written down. I just used the plus sign. I got 3 point, it says to the nearest tenth, so we'll use 3.5. So P is about 3.5, or P is about, go back to your calculator, and now do negative 6 minus 3 square root 10. And you get negative 15.5. I just want to show you something on your calculator that you might find interesting. If you don't want to retype something that you entered, you can see above the enter button, it says entry. If you do second and then the enter button, it rewrites what you had typed here. And now you could use your back arrow and like change that to a plus when you wanted a plus, or a minus when you wanted a minus. Back arrow plus. You know, so you don't have to retype the whole thing if you don't want to. But I'm not going to do the rest for you. It's time for you to practice and check your answers according to my list, and I'll answer any questions when I see you tomorrow. So have a great day. See ya. Bye.